Alright guys, you are welcome to Concept Understanding Lectures. Today we are going to talk about elasticity. In today's lecture, I will talk about the extent of deformation. I will talk about the graph of strained substances. I will talk about the proportional limit or the limit of proportionality. I will talk about the elastic limit. I will talk about the yield point. I will talk about the ultimate stress point. I will talk about the breaking point. I will talk about the differences between the limit of proportionality and the elastic limit. I will talk about what is the difference between the elastic limit and the yield point. I will also talk about what should come first between the elastic limit and the yield point. So I'll really advise that you don't skip around this video. Pay attention to details. Let's go. Elasticity is the ability of a substance to recover its original shape and size after distortion. Some texts may define elasticity as the ability of a substance to recover its original dimension after deformation. Distortion may occur in several ways, including when you place an empty bucket on a balloon. Suppose that you have a balloon that looks like this, and then by exerting a deformative or a compressive force on it, which is by placing an empty bucket on the balloon will be compressed in that manner. Suppose that after unloading the balloon, after removing the empty bucket, you still have the same height of the balloon. Let's call the height of this balloon, let's call it L. And the height of this other balloon is the same thing as L. Let's call this L1. L1, it recovers its original length. But the new length that was formed when you placed the empty bucket on the balloon, let's call it L2. Now it means that there is a change in the length, which implies that we can have the difference, which is L2 minus L1. L2 minus L1 is what is referred to as the extension or change in length. It can also be written as E. Now these are the properties of the strain of a material. Any material that is able to undergo this process is called an elastic material. It implies that an elastic material is a material that can recover its original shape and size or its dimension after distortion. The extent of deformation depends on two things. It depends on the nature of the substance, that is, the natural state of the substance. If you are trying to compress a stone, if you are trying to compress a stone, it is not the same way, it is not the same amount of force that is required for a stone. It's not the same amount of force that is required for a balloon, because of the natural state of a stone and the natural state of a balloon. Another factor that determines the extent of deformation. When I mean deformation, I mean distortion. That is the altering of the shape. When you are trying to alter the shape of a substance by either compressing it or by either elongating it. It can be tensile. When it is tensile, it means you are elongating the material. When it is compressive, it means you are decreasing the size of the material. Now, the second factor is the magnitude of the force. How much force is required? That's the second factor that determines the extent of deformation. Now, let us now suppose that we have a load on a spiral spring as shown below. Don't mind my diagram. I'm just learning how to draw with the Wacom tablet. Don't mind my diagram. Now, let us suppose that we have a spiral spring and the load is being exerted on it. This load is bigger than this load. Let's assume this is a 5 Newton load. and this is a 10 Newton load. Now, suppose that we have another load exerted on a spiral spring. If my drawing is not bad, please let me know in the comment section below. All right. Suppose that this is the 15 Newton force. If this 5 Newton force gives us a 2-meter extension, I have explained what extension means. The difference between the original length, the new length that is formed, and the original length, that is L2, which is the new length, minus L1, which is the original length. That is for compression. In that case, the body is being compressed. That means it will be negative. But in another case, in the case of an elongation, it will be positive because the new length will be longer than the initial length. So L2 will be bigger than L1. In that case, it will be positive. I will talk about that when we get to tensile stress and tensile strain. All right, let's continue. If the 10 Newton force produces a 4 meter extension and the 15 Newton force produces a 6-meter extension, it implies that the force in this case is proportional to the extension. If we assume that the force in all of these cases are proportional to the extension, that means all of these cases are obeying Hooke's law, because Hooke's law states that the force that is being exerted on a body or an elastic body is proportional to the extension, provided the elastic limit is not exceeded. I will explain all of that. If you continue to exert the load, a heavy load on the material, it will get to a point where the load will be greater than what the material can bear. As a result, the extension produced will no longer be proportional to the applied load. This point is called the limit of proportionality. In other words, the limit of proportionality is the point after which there will no longer be proportionality between the stress and the strain. Let's talk about the stress strain curve. I will explain all of this in it. A stress strain curve is a curve that shows the plot of the stress and the strain of a material on a graph. This curve may vary for different materials due to temperature and the loading condition of the material. Now let's have the diagram. The graph looks like this. On the x-axis, we have the strain. The strain is on the x-axis, and the strain is the fractional increase in the length. That is the ratio of the extension to the original length. Also, the stress, we have it on this side. The stress, and the stress is force all over area. Alright, the stress is measured in Newton while the strain is in meter. The strain is dimensionless because the unit of change in L is meters and the unit of L is in meters, so they cancel out. So it does not have a unit, or it is dimensionless. Now let's call this point O. Okay. From this point, from point O upwards, the graph shows linearity. It is linear up to this point. Let's have an arrow here. Okay. Now, from that point onward, let me use another color now. From this point onward, the graph is no longer linear. It is no longer linear. So I can call this point the breaking point. I will explain all of that in details. I can call this, okay, let's use the symbol ultimate stress point. That's U. And then this point is the proportionality limit, or the limit of proportionality. And then we can have something of this nature here. And then we can have something of this nature where this is the elastic limit. Also, we have the yield point. I will explain in details. You can have the yield points. These are the points, these are the stages that the material will undergo when the material is being tested. This graph, the essence of this graph is to show us the strength of a material, is to show the strength of the material. I will explain that as well. Now, from P, P is the point of proportionality or the limit of proportionality. E is the elastic limit. Y is the yield point. U is the ultimate stress point. And then B is the breaking point. The proportional limit is the point up to which values of the stress and strain remains proportional. What does that imply? It means that up to this point, up to point P, from O to P, up to point P, the values of the stress and the strain are always proportional. That is, they are always proportional. And if they are proportional, it means that the strain and it means that the stress and the strain are proportional to each other. And that implies that Hooke's law is obeyed in that point. Throughout this region, Hooke's law is obeyed because Hooke's law states that Hooke's law states that an advanced definition of Hooke's law is that the strain, let's assume the stress, let's assume this is the symbol for stress, is proportional to the strain. If this is the symbol for strain. Now, if I remove the proportionality sign, I will have an equal to and a constant. This constant is called elastic modulus. Now, elastic modulus gives the strength of the material. Elastic modulus helps us to determine the strength of a material. That means if I divide both sides by the strain, I will have the elastic modulus to be equal to the stress all over the strain. It means that the elastic modulus, if it is increased, the stress will be increased. If you exert how much strength, how much stress you exert on a material will determine the strength of that material. If the material can withstand a whole lot of stress, it means that the material has great strength. For instance, a stone will accept more strength, more stress than a balloon. It means that a stone has more strength than a balloon because it can accommodate more stress than that of a balloon. So increase in stress, increase in strength. If a material can accommodate more stress, the material will have more strength. But if it should be noted that the strength of the material, which is the elastic modulus, it determines the strength, shows is inversely proportional to the strain. Now, increase in more strength, less strain. More strength, more stress. More strength, more stress. More strength, less strain. All right, let's continue. After the proportional limit, there is a limit called elastic limit. Okay, before we talk about that, the stress up to that point can also be called the proportional limit stress. The proportional limit stress is the stress up to this point. All the stress from here to this point is called the proportional limit stress. Is the stress up to the proportional limit. Also, let's talk about the elastic limit. This is the elastic limit. The elastic limit indicates the limiting value of stress up to which the material is perfectly elastic. That is, up to this point, up to point E, the material will return to its original position if it is unloaded. Just like that of the balloon. If you remove the empty bucket that you place on it, the balloon will recover its original strength, the original dimension. I mean, the original dimension. And this is so because the material is perfectly elastic up to this point. It means that the region where we can find the balloon is in the region O, from point O to point E. But if the material cannot recover its original strength, it means that the material has gone beyond point E. Now, it should be noted that from point O to point E is the elastic limit. But Hooke's law do not apply. Hooke's law do not hold from this point. Hooke's law do not hold from this point onward. What does that imply? Because it is non-linear. It means that some materials, before they get to their elastic limit, they already deviate from Hooke's law. Many materials are found in this category. They deviate before they get to their elastic limits. Also, elastic limit is a point that indicates the amount of stress, that is this point. It tells us the amount of stress that is available in the material at the point of perfect elasticity. This is the point of perfect elasticity. This point tells us, it tells us the amount of stress that the material has at the point of perfect elasticity. Beyond this point, we have what is called plasticity or permanent deformation. Elasticity is also called temporary deformation because the material will be able to recover its dimension. But permanent deformation is referred to as plasticity. So before plasticity, we have the elastic limit. So elastic limit can also be defined as the point which shows the maximum amount of stress that the material can bear before permanent deformation. That is, before permanent deformation, what amount of stress, what is the maximum amount of stress that the material can bear? Elastic limit is the answer to that. Elastic limit gives us the amount of stress that the material can bear before the permanent deformation. All right, let's talk about, okay, before we go, we should talk about the difference between the proportional limit and the elastic limit. The major difference between them is that up to the proportional limit, material exhibits linear stress strain relationship. But between proportionality limit and the elastic limit, material exhibits a non-linear relationship and Hooke's law is not applicable. And that's why their gap is very, very small because they seem to be similar. In some cases, they coincide. From this point to this region, Hooke's law do not apply, even though there is elasticity. Hooke's law do not apply. But in this region, Hooke's law apply. The difference is that this is linear and this is non-linear. Also, let's talk about the yield point. The yield point, this is the yield point. It is the point that indicates the beginning of plastic deformation. It indicates the beginning of plastic deformation. At this point, the extension of the material takes place more quickly with little or no increase in load. It also indicates the maximum amount of stress that a solid substance or a material can bear at the onset or at the beginning of permanent deformation. It tells us the amount of stress, the maximum amount of stress that a material can bear at the beginning of permanent deformation. This one tells us before permanent deformation. It tells us the amount of stress that the material can bear before permanent deformation. This is at the beginning of permanent deformation, because from this place onward there is permanent deformation. There is permanent deformation. So this tells us the amount of stress that is available at that time. But this, the elastic limit, will only tell us the amount of stress that is available before. That is, it is considering the initial conditions. But this is considering the afterward conditions. Now, let's talk about the ultimate stress point. The ultimate stress point is the point that indicates the maximum strength that materials have to bear before breaking. After this point, if you exert any stress, the material may be damaged. As a result, the last one, which is the breaking point, at the breaking point is also called the point of rupture. At the breaking point, the strength of the material breaks. Now, the difference between the yield point and the elastic limit is that although the yield point and the elastic limit can be merged together as the same point, and sometimes they may not, but the major difference is that elastic limit indicates the end of elasticity, while the yield point marks the beginning of plasticity. It means that the yield point is after the elastic limit, and the gap is very, very small. In fact, upon the application of a very small force, a force that tends to zero, so this gap is a very, very small gap. Upon the application of a force that tends to zero, the material will move to this point. Some text may replace elastic limit and yield point, but I just want to be general so you will be able to know the difference between the elastic limit and the yield point. I hope you learned something in this video. Put it in the comment section below. What do you feel about this video? Let me know in the comment section below. If you really understand me, put it in the comment section below. If you have any question, put it in the comment section below. Make sure you share this video with your friends. Have a nice day, and make sure you subscribe so you can have more of this video, and like. Thanks.